Now let's move on to check other assumptions. Here we have two distributions that both have mean 0, so the null hypothesis is true. They're both normal. We're going to draw 50 points from each of them, but here the variance is 1, and here the variance is much larger. Here the variance is 9. And yet we're still going to do this test that assumes equal variances, because we want to know whether this test is robust to the assumption of equal variances. And lo and behold, it pretty much is. 5% of the time, we get a p-value less than 0.05 by assuming equal variances when actually those variances are not even equal. What if, though, I have the left with a variance of 1 and the right with a variance of 9, and I draw very different sample sizes, 50 points from the left and 500 points from the right? Now, finally, I've broken my t-test. The pooled t-test that assumes equal variances won't work if the variances are unequal and also the sample sizes are very unequal. And the way in which this doesn't work is I never get a p-value less than 0.05. In fact, the p-values are huge, right? It's very unlikely I'm ever going to reject anything. I'm not going to have a lot of power to this test because I'm really never going to be rejecting anything. What if I switch the sample sizes? The distribution on the left has variance 1, the distribution on the right has variance 9, but now I'm going to draw many more values from the left. Again, I've managed now to break the t-test. Now, when my type 1 error rate, the probability of rejecting the null when it's actually true, should be set at 0.05, now I'm rejecting the true null hypothesis 37% of the time, and that's clearly wrong. And that's because the variances aren't equal, and I'm assuming they are equal, and the sample sizes are very different. What's the solution? Well, I could use the Welch test, the unpooled test. And if I do that, everything's fine again. So for this equal variance assumption, when the sample sizes are equal, the pooled t-test is fairly robust to unequal variances. It's only when the sample sizes are not equal that the pooled t-test doesn't really work, but if you use the unpooled Welch test, everything's fine. How do you check? Graphics. Again, there are tests available, but why would you want to make a decision based on an arbitrary p-value cutoff in order to make another decision based on an arbitrary p-value cutoff? Rather, just look at your data and see if the variances or the spread of the two distributions appears to be kind of close. When the equal variance assumption isn't true, you can use the unpooled test or transform, but also if the sample sizes are equal, it's probably fine for the variances to be different. So here's some examples from a data set that has to do with birds, just different ways that you can see here the spreads of these two data sets are kind of close, right? We could compare the widths of these two box plots. Close enough. I would say in this data set the variances are close enough to equal. And this is the best way to check. You don't need a test that tells you whether the equal variance assumption is met.